guys, I am Alferos from ECE31 and I am here to present my experiment number 2 about digital input. For the objectives of our experiment, we have to learn how to create a project and build a project, to understand how the final code programmed to the microcontroller, and to create a simple code for controlling an LED. For our equipment and components, we need PIC16 F18875, 220 ohms resistor, LED, breadboard, connecting wires, PIC 3 or 4, and power supply. So, to give you a glimpse about digital input, this project demonstrates how to read a digital input on a microcontroller and control a light emitting diode or LED based on the state of a momentary switch connected to the digital input. So, based from our experiment number 1, digital output, this time the comparison is that, or the difference is that we will use a switch. Using the MPLAB code configurator or MCC, this simplifies the setup for the various registers within the device to create a digital input. To demonstrate how to get started, this project monitors a momentary switch connected to pin RB4 that is enabled as a digital input using an internal pull-up. The code will light up an LED connected to RA4, enabled as a digital output when the switch is pressed. So, first things first is to go on our MPLAB X IDE, new project, standalone project, next. Let us find our device, the PIC16 F18875, there, next. Our compiler, next. And our project name, let's name this as EXP2. And finish. Then go to Tools, Embedded, and the Configurator. Then select MCC Classic and finish. Then after that, we're going to see our peripherals, which consists of interrupt module, pin module, and system module. So let us click the pin module. Since we are dealing with RA4 and RB4, all we need to find is the GPIO output and click 4, as well as also 4 here. There you go. And on the upper portion on RA4, we just have to rename it with LED, while RB4 with switch. We just need to uncheck the analog, uncheck the output of RB4 only, while checking the WPU of RB4, letting the output of RA4. Going to the system module, let us select high frequency internal oscillator 4 MHz 4 and check the low voltage programming enabled. After everything else, click generate. So after generation complete, we all need to do is go to projects, our source files, and our main C file. Going down is that we will see this while wherein we are going to input our first part of the code, wherein turning on the switch will turn on the LED and turning off the switch will turn off the LED. So let's do the code. Enter, then if switch underscore get value, then equal 0, then enter, then LED underscore set high, and there. Else problem in the code, so let us click the hammer like button, build. After loading complete, we just need to insert our USB port of the Piggy 3 on our laptop. There you go, and our Piggy 3 will light. So I have pre-inserted already the terminals of the terminal 1 to pin 1 of the IC, terminal 2 to pin 11, terminal 3 to pin 12, pin 4 to terminal 40, and the fifth one to 39. And we can now proceed to our MPLAB X IPE. We are now going to connect our device since it is already recognized by the MPLAB X IPE. Just click OK. So it has a warning wherein target device was not found. So in order to resolve this, just go to settings on advanced mode and type microchip since it is the default password. And under advanced mode, we are going to have additional options. Go to power and set the voltage level to 3.125 only. And power target circuit from Piggy 3 must be enabled. Go to operate and browse our hex file. And here is our hex file for experiment 2. Just open it. So hex file loaded successfully. We can now program our microchip. Click OK. And after a few moments, programming complete, we can now remove our USB port and proceed to the hardware. So for our hardware, I have already pre-assembled it, wherein I have connected negative terminal to the ground and the positive terminal to the positive. And then on the IC, all VDDs on both sides will be connected on the positive terminal, while all VSS will be connected on the negative terminal. So all VDDs are on 11 slot and 32nd slot, while all VSS are on the 12th slot and 31st slot. So for the connection in the LED, on the 6th slot RA4 going here, and then a resistor 220 ohms was connected there, series to the positive of the resistor, and the negative of the LED was connected to the ground. And then I have here the switch. Since our activity is about digital input, I have inserted the negative of the switch in the ground and the positive of the switch on the 37th slot, which is the RB4. So let us now supply it with our voltage supply. There you go. So as I turn this on, it must be on, while I turn this off, it must be off. So let's do this. There, on, there, off. So on the next condition, we must modify the code in the main C file such that the LED will blink at 2 seconds interval once the button is in RB4 is pressed. So since we have a delay here, so we are going to put or insert the delay code or command. So enter underscore ms. Since 2 seconds, of course 2000 milliseconds, and then instead of set high, we must toggle it since there. And after that, let us click build. So after doing the same process, I have already programmed it again, and let's try this. So this time, if I turn this on, the LED must light up for 2 seconds and light off for 2 seconds and light on for 2 seconds again, so blinking for 2-second interval. And if it is off, then totally off. So let's do this. And our very last condition, create a program that light the LEDs in RA1, RA2, RA3, and RA4 after the button is pressed in 1 second in RB4. In order to do the part 3, so let us proceed to the pin manager. Since there is an addition of 3 LEDs, so we just need to click the port A number 1, 2, and 3 respectively. Then go to pin module, wherein we are going to unclick this, and this, and just rename this as LED 1, LED 2, LED 3, LED 4, and still as switch. Finally, after doing that, go to resource management to proceed to generate. And on the main C file, I already pre-typed the code wherein I modified it such that we are using additional 3 LEDs. That is why I inserted LED 2, LED 3, and LED 4 as set high on the delay MS of 1000. Else, LED 1 to 4 will be set low. So, let's build the code. And finally, I have done my circuit wherein the same idea or the same concept just like the previous, but I just added 3 more LEDs. So, if I turn this off, it means it is off, but if I turn this on, it will be on with a 1000 millisecond delay. So off, then on. Off, on. And now to conclude, I can say that MPLAB X IDE, MPLAB X IPE, and these devices, hardwares are used for this type of experiments and applicable to some real-life applications like the Christmas lights. And for my conclusion, digital inputs are binary inputs 0 or 1 that are applied to the PLC. Binary inputs are basically voltages varying from 5 volts to 230 volts depending upon the type of card used. In simple words, any push button, switches, or sensors produces digital inputs to a PLC. Digital inputs are used to check the status of any devices whether it is on or off. For an input module of 24 volts DC, 0 volts DC acts as off state binary 0 and 24 volts DC acts as on state binary 1. So on our experiment, the on state is on the 5 volts while the off state is the 0 volts. And that's it. My experiment number 2. I hope you like it and you learned something. Thank you and God bless.